Hello, I'd like to welcome you all to our webinar today. My name is Larry Pearson, and I'm Vice President of Marketing at Impetus Technologies. And I have the pleasure of being your host and MC for today's session, which is entitled Accelerate Your Journey from Data to Decisions, a Unified Analytics Platform for ETL, Machine Learning, and BI. Now, for those of you who may not be familiar with Impetus, we are a group of companies headquartered right here in the U.S. in the heart of Silicon Valley, and we distinguish ourselves in a couple of different ways. First, we specialize in helping large corporations with what I like to call all things data. And in most cases, that means helping them achieve what is commonly referred to as a single source of truth. That's actually what has inspired this mission statement that you see on your screen right now. Secondly, inside of that specialization, our offerings span the full life cycle from technology strategy and cloud migration through big data processing, advanced analytics, BI, and even DevOps. And having solutions that span that full range of offerings means that we can help you wherever you may be in your enterprise analytics journey to address the challenges you may face and help you take that next appropriate step. Today, we will be focusing on how two of those offerings, Stream Analytics, an Impetus software product, and an offering from our sister company, Skywars Insights, will provide a BI acceleration solution, showing you how these solutions can combine together to deliver a powerful unified enterprise analytics capability. And we'll actually show you a live demonstration of what that unified user experience looks like. So we've got lots of ground to cover for you today. Let me start by helping you by taking a quick look at the agenda today. First, we'll be talking about some of the challenges that our industry faces in offering their users a unified analytics platform, and the opportunity that represents. We'll provide an overview of both the Stream Analytics solution and the Skywars solution, and again, how they integrate together to offer that unified platform that you're here to learn more about. And that will be done in the form of a live demonstration, as I said. I would remind you again to please send your questions in at any point in time. The other way we add a little bit of interactivity to the experience today is by a couple of polling questions. And you'll see that polling question come up on your screen now. It is in two parts. And the first says, in your data transformation journey, which of the following are your top two concerns? Onboarding new sources and addressing the complexity of data integration and the proliferation of different data sources from an ingestion standpoint, data preparation and enrichment, real-time availability of data for consumption and dealing with the availability of streaming and real-time sources, and lastly, the scalability of your ETL workflows, and maybe the fact that you actually have multiple solutions which you're using to address ETL, and how that again can be better addressed through a unified approach. So that's on the data transformation side of your journey. On the BI side, the questions that we would ask is for you to identify which of the following are your greatest challenge: inability to query data at scale, or the challenge of achieving the required latency expected by your users and represented in your service level agreements with them, presenting a consistent view for users across a wide variety of data sources and requirements for transformation, or lastly, all of the above. So this poll question will remain open for the next 10 or 15 minutes. Would ask you to respond to both aspects of the poll, and I'll actually come back to you then and show you the results of that, and that's always a very interesting part of our webinar experience. A brief introduction of my colleagues who will be with me today as subject matter experts. First, Ajay Anand is Chief Product Officer with Skywars Insights. He's an industry veteran with more than 25 years of experience in creating best-in-class solutions for enterprises in the areas of business intelligence, distributed computing, and storage. And he leads our core product engineering team and actually has been instrumental in shaping the functionality and architecture of the product since its very inception. Previously on and led product management for Hadoop at Yahoo, and after that was a co-founder of Datamir. With him also today is Amarjeet Singh Khalsa, who is a product manager for Stream Analytics. Amarjeet is also a member of the core team that developed the Stream Analytics product and is involved in helping guide manage the customer or the product roadmap, leading implementations, and involved in customer engagements to assure that that roadmap represents their best set of interests and needs. The third subject matter expert with me today is Nidhi Mittal. Nidhi is a solution architect for Skywars Insights, and she has more than 10 years of industry experience and is a key member of the Skywars team and spends her time translating business and functional requirements into actionable insights for Skywars customers. So I hope you can see we've got a very, very highly qualified set of panelists, and excited to be able to start this off by asking Ajay to kick things off. Ajay Anand, Chief Product Officer from Skywars Insights.
Thanks, Larry. So enterprises today are faced with an environment where data is growing exponentially and arriving at tremendous speed. And it's coming from a variety of data sources and in different formats. And they're running into limitations of their traditional BI tools and infrastructures to keep up with the volume and velocity. So they're looking to the cloud to see if they can leverage the cloud to deal with the issues of scale and speed to control their costs. The key, after all, is how quickly can you take advantage of this data and make the decisions that are necessary to drive your business. So let's take a look at a few real-life examples and customer scenarios. The first one we're looking at is a leading content streaming platform. They do viewership analytics. Now, as you're well aware, these organizations are seeing a tremendous upsurge given the current climate. But it is imperative to act quickly and understand viewing patterns across a variety of devices and channels and combine this with demographic information and other sources of information related to how the content is being viewed. To really understand where to target and promote the content, how to demonstrate ROI for advertisers, how to increase viewership and reduce churn in a highly competitive environment where there are a huge number of choices for the viewer. Ingesting all of this data, quickly understanding patterns, and applying machine learning techniques, doing data cleansing, landing the data in a scalable infrastructure, and then providing instant and interactive analysis through their BI tools and through the data science tools of choice. So dealing with data which can be millions of records, hundreds of millions of records daily. Overall, they're analyzing over 100 billion records, and they're looking for instant response time for their BI users. And you'll be seeing some of this in the demo shortly. The next use case is a leading software provider. And they were looking to analyze their customer journey across multiple products, analyze the customer experience across multiple touch points. Previously, data was in multiple silos related to either transactions or customer support or product usage. And when their executive team or their CEO asked a question, the answers were inconsistent across these multiple silos. So they embarked on a journey to bring all of this data together in a data lake so they could get a consistent single source of truth, but still have the ability to query all of this data. And as you can see, hundreds of billions of rows with instant response times. And here they were looking for really challenging data sets. They had data coming from all of these different places. So they've got, for people who are familiar with how BI tools work, you've got 9 or 10 fact tables, 10 or 15 dimension tables. All of that needs to be combined together to give a consistent view across your enterprise. The third example we're looking at is of a financial institution where they wanted to examine patterns of fraudulent behavior across zip codes and across merchants and quickly identify anomalies and look at trends. It was necessary to combine a huge amount of historical data with real-time data coming in. This needed to be blended together. Data needed to be quickly prepared and cleansed. Models were applied for scoring, clustering, categorization, so that time to insight was reduced, and they could really understand the patterns of fraudulent behavior and take quick and corrective action. So we can see that data is opening up tremendous possibilities and opportunities for enterprises. So they now have access to more data than ever before about their customers, about transactions at the most granular detail, about interactions across all possible channels, interactions on the web, on mobile devices, really generating hundreds of billions, trillions of data points. So the opportunity exists to really utilize this data to transform the decision-making process at businesses. But it's a double-edged sword. They need to act quickly in order to stay competitive and succeed. Time to insight is critical. How quickly can you ingest and make sense of all this data, apply intelligence to it, clean it, make it consistent, get it in the hands of business analysts and data scientists, and give them the ability to deal with this data in a self-service, interactive way and get instant response times. And in order to stay competitive, really the ones that succeed, the enterprises that succeed are the ones that can really take advantage of this data, solve these challenges of ingestion, of analysis, and make this data available to their analysts who are key to making decisions for driving their business. So we're looking at a combination of two different things. Dealing with the data at tremendous volume and velocity, being able to ingest that in a self-service way and do ETL and transformations, clean up the data, and then the high-performance BI. Once your data is ready for analysis, now you want your BI users to be able to interact with it instantly. They don't want to be submitting a query and waiting for minutes. And in traditional systems, they could be waiting for hours to get a response. Combining all of this data in some of the examples we just looked at, combining data from different silos, this could take days to really get an analysis done. There's a customer in the financial services space looking for doing risk analysis across multiple touch points, and they had to really run queries across all the different data warehouses, bring all the data together manually in spreadsheets, and it could take days to process the information. So it's really imperative to succeed in this current climate to be able to reduce the time taken from the point where you get the data to when you make your decision. So the solution that we're going to be looking at is really combines address both problems. So the two products we're going to be looking at, the first is Stream Analytics and the other is Skywars, and how they work hand in hand to deliver an end-to-end solution. So Stream Analytics takes care of ingesting and transforming data from all kinds of data sources at massive volumes and speed, providing the ability to apply machine learning on the fly, landing the data in your data lake of choice, regardless of which cloud platform you choose. It could be Amazon, could be Azure, Google Cloud, perhaps a cloud data warehouse like Snowflake. It could be an on-prem data lake like Hadoop. But once the data has landed in your data lake, now you need to make it immediately available to your business users. So that's where Skywars kicks in. It takes all of this data, builds multidimensional cubes at unprecedented scale, so that now business users and data scientists can use their tool of choice, connect to trillions of rows of data, and get instant interactive insights. And the reason for building these cubes is so that you can pre-process the data, make it all ready, and do all the computations up front, so that when a query comes in, now you can respond to that data instantly, and you don't have to be trying to run heavy-duty queries, trying to process large volumes of data, doing joins across multiple tables, doing group bys across large data sets. All of that takes time. So you want to eliminate that from your decision-making process and do that up front, so that now you can make the data available to your business users and also your data scientists. So all of your users can connect to a single consistent view of your data. Use your BI tools. You can use Excel, you can use MicroStrategy, Tableau, Power BI, whatever you choose for your BI users. And your data scientists can connect to it using R or Python and be able to run their algorithms connecting to the same data. And in the demo, you're going to see this in action. So now let's take a look at each of these tools in a little more detail at the features that they provide. So the key features on the Stream Analytics side, it's a complete data 360 platform. So it provides a complete self-service data ingestion and transformation platform, dealing with both real-time and static data sources using open source technologies. So you can create your workflows for ETL and machine learning at enterprise scale. And it provides an easy visual interface to quickly design these workflows, but also provides a robust solution designed for enterprise-grade deployments with end-to-end lifecycle management. So this does the data ingestion, data cleansing, change data capture, CI/CD pipeline development, all on your cloud platform. And it provides the ability to incorporate machine learning right here. As you're ingesting your data, you can run machine learning algorithms to do whatever clustering, categorization, or other models you want to run on your data to get even more insight and understanding of your data as it comes in. Once your data lands, that's where Skywars takes over. So here we're using smart OLAP technology at data at tremendous scale. So this is massively scalable. And what Skywars does is we create a semantic layer on top of this data and does the computation and pre-aggregation of this data to enable delivery of instant response time queries from your BI or data science tools. It's designed to run natively in cloud infrastructures so that it can build multidimensional cubes at unprecedented scale. And this is extremely important. If your tool is not designed to take advantage of distributed computing at enterprise scale in your cloud infrastructure, trying to port a traditional application over and expect it to take advantage of the cloud is really not the way to go. So this has been designed to really scale out as you need it. And as new data comes in, it gets seamlessly added to the cube with no disruption to the users. So the solution is horizontally scalable, and cubes can be built at massive scale with no compromises. So now you can slice and dice data sets with trillions of rows, interactively drill down to the most detailed levels of granularity. And since the data has been pre-processed into the cubes, business users and data scientists don't need to run expensive and time-consuming queries on raw data. So this can scale out to deal with thousands of users without exponentially increasing costs. So to summarize, the benefits of the combined solution you're about to see, it solves the problems of data ingestion, transformation, creating an end-to-end pipeline and workflow so that data is brought in, combined, profiled, built into multidimensional cubes, and made ready for instant analytics from your BI tool of choice. For data scientists, machine learning can be seamlessly integrated, both on the incoming data as well as on the processed and historical data to get insights at unprecedented scale. So with that, let's see this in action. Over to you, Amarjeet. Oh, there's poll results as well.
Thank you, Ajay. Ops team, if you could close the poll now and share the poll results. We'll move to that prior to moving into the demo. You should see the poll results shown on your screen here momentarily. You'll recall that the poll had two parts. The poll question had two parts to it. The first said, in your data transformation journey, which of the following are the top two challenges that you face? And here you see the responses to that. There were 5 options. The one, or the top two really, are addressing real-time availability and also the complexity of data integration and the data ingestion choices, each at 47% and 41%. So thank you all for that. The second part of the question said, in your current BI journey, what is your greatest challenge? And we look there, and far and away in the BI side of the life cycle, we see that all of these things represent challenges, with fully 65% of our audience saying, yeah, we have challenges in all those areas. So thank you again for responding to the poll. We'll jump now over to the demonstration, and that'll be done by Amarjeet. But I would remind you all again, at any time you can enter your questions, and we've got time set aside at the end for that. So Amarjeet, it's over to you.
So thank you, Larry and Ajay, and hello everyone. So today's demo is on streaming video on-demand platform story, something like Netflix, Prime, or Disney+. Now, as we all know, hosting the right content is the key for all these platforms. And to understand a content's true potential, we need to get answers to questions like which movies are actually driving my subscribers count, or what's the week-over-week viewership pattern, or can we get a forecast trend for a given genre so that we get to know whether comedy will be trending or thriller will be trending. Now for that, we need to analyze all kinds of data. So now here we have 2.2 billion viewership records. We have gathered this from 96 million subscribers and over a span of 5 years. So let's get a better understanding of the data we are dealing with here. Okay, so we have viewership data, right? It's a plain CSV. It requires cleansing, deduplication, enrichment, and finally, partition storage in S3. So basically, if you look at it, it's a typical ETL flow, but our focus will be on how easily we can achieve it in Stream Analytics and how scalable those ETL pipelines would be. And then we have subscription data. This one is residing in Microsoft SQL Server storage. It's coming from a database table. We'll be performing CDC on it and creating a single source of truth for it in S3. Then we have movies data. It's a complex nested JSON. Our idea is to flatten it out and use it in our viewership analytics, right? So as you can see, we are reading from a variety of sources in different formats, right? And once all these ETLs are done in Stream Analytics, it will trigger a cube build. Now that cube build will create a Skywars cube, which will be massively scalable OLAP cube, right? And you can get answers to all your business queries, as Anand mentioned, through that cube, right, in a matter of seconds. And when you're firing those queries, you can fire them from Excel, Tableau, Skywars native interface, or Python. Along with it, we'll also be querying that cube in Stream Analytics. And we'll be querying a massive amount of data, and we'll be actually getting aggregates on it and training a machine learning model on top of it without writing a single line of code. So that's what we plan to do in this demonstration. So let's get to it. All right, I hope my screen is visible to you all. All right, so what you're seeing is Stream Analytics web interface, right? And each tile here represents an ETL flow, right? And once you create these ETL flow, we actually call it data pipeline. So once you create these data pipelines, you can configure them on Databricks or EMR, right? You can choose whether they will be running alongside another jobs or they get their own dedicated cluster. And while you do so, you can configure their capacity requirements. And whether they'll be needing any auto-scaling rules, you can configure those rules here. Whether they'll be running on demand instances or spot instances. So, you can configure their capacity and how they behave on a cluster. So once that is done, right, and you start this pipeline, it will be running on the pre-configured settings. But the idea is you don't need to set up all these things in EMR or Databricks. You can do it from right here where you are creating your ETL jobs. So let's see how we can create one of these. We'll be starting with our viewership ETL, that's our viewership analytics pipeline. So to create an ETL flow like this, we can drag and drop components from the palette on the right, as you see, right? We connect them and define our business logic or data flow, as we call it. So now, palette is divided in 4 sections. The first one being sources. You can read from real-time sources or batch sources, And there could be structured, unstructured, semi-structured, and it could be in a variety of format, be it Parquet, Avro, JSON, CSV, and whatnot, right? So once you have read the data, you can transform it using all these operators. We'll see a couple of them in our demonstration as well. Then we have machine learning operators. Now you can use these in two modes. You can use them in training mode. So the incoming stream will be actually training a model. But if you already have a trained model, you can actually leverage that model and use these operators in prediction mode so that a predictive score can be generated on incoming stream and enriched into it. And once your data is completely transformed, you can save it or you can persist it at the desired emitter, right? In choice of your format, right? So basically that's what this palette allows us to do. Another interesting thing about creating all these ETL flows in Stream Analytics is you're actually working with your data. So now if I click on this viewership icon, right, I'm reading my data directly from S3. I get to see my columns in the viewership data set, their data types, various values, and whenever you click at any stage, you get to see how your data gets transformed at that stage. So think of a traditional system where you'll have to build a complete ETL flow, you'll have to deploy it on Databricks or EMR, and then wait for the results to come up, validate them, and finally rectify the process. You don't need to do all that. It saves all that hassle because if you see any error in your functional logic, that will appear right here, and you can rectify it as you see it, right? So it saves a lot of time and makes your development really faster. So let's see what we are doing with our viewership data here. So I read a viewership data, all right? Then I pass it through my data quality operator. So this is the place where I've defined all my quality rules. So data which meets my quality requirements, only that stream will be moved forward for the ETL processing. The other part will be moved to an error queue where you can analyze it for, all sorts of reasons and take the necessary actions. After I have received the quality data, we are just dropping our duplicate records here. Now, one more thing we analyzed while looking at our viewership data. There were quite a few records where device category was null. So what we did is we trained a decision tree model, so which will actually predict the device category for us based on device OS, its screen size, or browser. So I'm splitting my stream in two parts. One, where device category is not null, that goes straight to the union operator, and where device category is null, that portion goes to the decision tree, where I'll be using it to predict the device category. And once I have the device category, I'll enrich it in the stream, and finally, will union it with the previous stream. So at this point, at union operator, I have records which are clean, which are not duplicate, and they have device category populated in every record. So I have a clean viewership data, correct? This point, I would like to enrich it with my movies data. So as we discussed earlier, it's actually a nested JSON. So if you look at director has information at one level and review actually goes deep down. So when we are doing all these operations, right, we would like to flatten it out. So that's why I'm passing it to a field flattener. Now what field flattener does here is, it will traverse through all JSON paths. It will fetch the value nodes and it will bring them on top, so that you actually see these nodes as a column in your table, as opposed to, traversing all sorts of JSON path to get to the value. So after it's flattened out, it's linear. I'll be joining it with my viewership data. We'll be deriving all sorts of movie attributes, and finally, the refined data will be saved in S3, right? Where Cube can actually leverage it. So now, at this point, Cube will actually take advantage of completely processed data, which has all sorts of information coming from variety of sources. So that's how we are processing our viewership ETL. Let's talk about our subscription data. Okay. All right. So for subscription, okay, before even we get to it, so when during our interactions with large enterprises, now they could be from telecom domain or various industries actually, but the idea is, what we came across is that they all have a lot of data in their OLTP platforms, right? So they're transaction systems. But the challenge is they would like to run all sorts of analytics, but they're limited by the capacity of it. So that's where they would like to migrate these things on S3, Hadoop, Hive, right? But it's not a one-time migration. They would always like that their target is up to date and in sync with the source systems, right? So that's where the process of change data capture or CDC comes into play. Now, but when we talk about CDC, there are a variety of databases. Each one of them has, various versions. And in a typical enterprise, you will find out hundreds of tables in there. And it's very hard and very cumbersome to create CDC process for each one of them and maintain them over a period of time, right? So that gave us the idea of creating CDC applications in the system in stream analytics. So essentially what we are doing here is we just specify what is our source and what is our target, okay? And what exactly we want to capture in CDC process, right? That's all we need to do. Behind the scenes, system will create an ETL flow, which will ensure the smooth implementation of change data capture process. And not just that, when you run it, you will get to see how many records got inserted, updated, or deleted. So it's a completely transparent system, right? And gives you the power to configure them, to define the capacity of cluster where it will be running. So you can actually cater to different use cases. So there could be a use case where you need a smaller cluster, so you can configure accordingly, right? So now with that, let's take a look at how we are transforming our subscription data. So I'm reading it from SQL Server, just making sure that I have required privileges. Yeah, I've selected just one table. You can select as many as we like to capture CDC for. This is my target, my bucket, and the folder location in S3. And here you can choose the columns you would like to capture during the CDC process. If you want, you can drop certain columns, and we'll be doing a type 1 CDC over here. Next, next, next. You can schedule it if you like, so that it gets executed at a particular time. So that's all. See, we just specified metadata information and source and target details, and we are good to go, right? So that's how we are transforming our subscription data. Now, we know how we transformed our subscription data, and we also have our viewership ETL pipeline ready, correct? With that, all we need is the way in which we can trigger an automated mechanism which will call these flows at the right time, correct? So one possible solution could be just schedule them at a specified time. But if you look at viewership data, right, before you invoke or process your viewership ETL pipeline, you need to make sure that movies data is up to date, which is the responsibility of movies ETL pipeline. So now I just cannot schedule it, because if I do so, there may be a point in time where movies data is not up to date. So viewership pipeline will, may lead to errors. So that's where, to show these dependencies, we came up with the concept of workflows in stream analytics. Yeah, just give me a second. Yeah. So so what we see here is I'm able to express the dependency between movies and viewership. So as soon as this workflow starts, right, the viewership will only be invoked when the movies data is completely and successfully processed. And since subscription is not dependent on this flow, it can always start in parallel and run on its own cluster capacity. And at any point in time, if you want to get notified for successful execution of a pipeline or its failure, you can configure an email action, you can make a call to Python script, and there are a bunch of operators which are available here which can help you. So with that, once my viewership data and subscription data is completely processed, I'll be making a call to HTTP operator. Now, this in turn will invoke the cube build, right, where we'll build that OLAP cube, and how that cube will work, what are its internals for that, I'll be handing it over to Nidhi. So over to you, Nidhi.
Yeah, thanks Amarjeet for this great demo. So we can't imagine how much stream analytics has simplified the process of complex ETL and data ingestion requirements, especially on cloud platforms for our customers. So it has helped them to reduce their implementation cycles from weeks to hours and get cleaner data on data lake that they can use for their further BI and analytics needs. So given that this problem is now solved for us, so let me show you how we can use Skywars to consume this data. So on my screen, you can see Skywars user-friendly interface that allows user to design and manage Skywars cubes with simple drag and drop features. So this Skywars instance is currently deployed on AWS Cloud, and similarly, it can be deployed on other cloud platforms also like Azure and GCP. So as Amarjeet said, that data will be available after the ETL processes completely on S3 Data Lake. We can create H catalog tables on top of their data, and we can register those tables in the form of files in Skywars, as you can see on my screen. So this is a fact viewership file, for instance, which has been created on this particular fact viewership table. It's nothing but an H catalog table. So once these files are registered in Skywars, they can be further used for data modeling and cube designing purposes. So now I will talk about two key applications of Skywars, the relationship designer and the cube designer, followed by the Skywars native visualization layer. So let me switch to the Skywars relationship designer screen. So on my screen, we can see three tables which are connected in a simple star schema. I have simply dragged and dropped these tables from this left panel here and connected them together using the joining keys. The fact viewership table is connected with the dimension movies using the movie title, while it is connected with subscriber using the subscriber ID. So now let me talk about this data first. So this fact viewership data contains information like when the movie was watched, for what duration, who watched it, and on which device it was watched. Similarly, this movie dimension data contains information like title, genre, release date, and content rating. Subscriber information contains demographics information of the subscriber like state, county, along with its subscription type. So now we can see this is a simple star schema, but Skywars can also model different other schemas like snowflake schema, multi-fact schema, single file schemas. So once this data model is ready, it will act as a source to the cube designer screen, which we also call as our universal semantic layer, like using which you can pick and choose any BI tool of your choice and connect using either MDX or a SQL connection. You can also connect this universal semantic layer using your data science tools using JDBC and ODBC connections. Now let me show you the cube designer screen where we will create a cube design on top of the data model. In the left panel, we can see all the candidate dimensions and measures from where we can pick and choose what all dimensions like hierarchies and attributes you want to keep in the cube along with the measures. Now here is a list of dimensions that I have added into this cube. For example, this viewership dimension contains this multiple hierarchy and required attributes like device OS, which has this hierarchy of device category, OS, and size. Similarly, we have this hierarchy of viewing weeks and these attributes. There is another dimension like subscriber location, which has a hierarchy of state and county. So I can actually drill down to the county level to analyze the subscriber level viewership information. So this way I can actually choose what kind of granularity I want to keep in the cube. So once all these dimensions are designed and defined, we would need to define the measures here. Like this viewership is a measure of function count, which is defined on number of days. I also have these different functions available on top of which I can calculate my aggregates in the cube. So once these measures are defined, I can also define calculated measures, which are MDX expressions like this. And these can be defined anytime, even after I have designed and built the cube. So once the cube is designed, I will do a full build on the cube to add all the historical data. Similarly, we can also do incremental builds to add daily incremental data, and this will provide seamless experience to the users without any downtime. So once the cube is designed and built, it is available for us to consume through any BI tool of our choice using either MDX or a SQL connection. Now I'll switch to a dashboard that we have created on our native visualization layer. We call it as a viewership content analysis. This dashboard is actually querying 2.2 billion viewership records across 96 million subscribers and has around 5 years of data. So now let me choose 1 year out of those 5 years to analyze the movie's data. And I can see how quickly the dashboard got refreshed in sub-second response time. So Skywars smart OLAP technology has enabled us to interactively query the cube and get these instantaneous response times on the dashboard. So this first widget is actually giving me the top 10 movies by viewership. And I can see Jurassic World has the highest viewership. Suppose I want to analyze data for this particular movie. Let me click on this movie. And I can see all the other widgets got refreshed with the Jurassic World viewership data. So in the second widget, I can see that the day second has the highest viewership from the release date. Similarly, the third widget is giving me that a standard subscriber has the highest viewership and they have watched this movie on device television. So these kind of powerful insights can be derived out of this dashboard. So let me go to the bottom part of this dashboard where I can see a heat map, which is giving me the distribution of viewership across various states. And I can see that California and Texas has the highest viewership for this movie. Now suppose I want to drill down to a county level and see the distribution of the viewership against that. I can simply do a drill down and it will give me a distribution of viewership across various counties in Texas. And now if I click on a county which has the highest viewership, the whole dashboard will get reflected with the viewership information of that county. So these are the kind of powerful insights that we can derive out of this dashboard. And it can help me give like smart content buying decisions. We can also provide subscriber level recommendations to the users. It can also be used by marketing and advertising for their marketing pushes. So currently what we are doing is an interactive analysis on top of cube data in this dashboard, but we can also leverage the Skywars cube data for doing data science, forecasting and prediction analysis. So let me switch to a dashboard which is giving me forecasting numbers for a particular movie which is released in a particular genre. So here we can see the upcoming 20 weeks forecasting numbers which were calculated using a data science algorithm on top of Skywars aggregated data. So these are the different data science algorithms that we can run on top of Skywars cube data, but we can also leverage stream analytics to train these data science models and come up with these forecasting numbers. So now I will have Amarjeet to show us how we can actually train these data science model in stream analytics and leverage Skywars cube data there. So over to you, Amarjeet.
Thank you, Nidhi. All right, so what we have here is, so as we see, there's a massive amount of data that goes into Cube, right? And Cube has the power to get the insights out of it within seconds. Right? So think of a scenario where we have to train a model on aggregated data for 2.2 billion rows, right? So first you'll have to aggregate that data in a typical ETL pipeline. That will require a lot of infrastructure and time. And once that is done, you will be feeding it into machine learning operator, correct? So, but since Cube has already done it for us, what we'll be doing is we'll be querying Cube directly into Stream Analytics. It's as simple as, implementing a JDBC connector here. So I'm referring to Skywars connection. We'll be firing this query, and that's it. So with that, we have read the Cube data, aggregated data actually from Cube in this JDBC operator, and we'll be feeding it to this random forest operator. Now, we are using it in the training mode. I'll be training a regression model, random forest, and that will be for our genre analysis. So I select my features. We would like to predict our viewership count as we saw on the dashboard, and there are a bunch of continuous and categorical features which we have selected for it. There are a variety of transformations available here that can help you in pre-processing your data. So for instance, I've used a feature hasher to club all my categorical variables here. So after my pre-processing is done, I'll configure my model, All right, so you can specify all the properties of random forest here. It's all configuration driven, so you actually don't have to write any piece of code here. Now, by this point, you have provided all the configurations which are necessary to train a model, right? Now, you can actually specify the evaluation details. So what we are doing here is we are specifying that our training to evaluation ratio would be 80% to 20%. So my 80% of data would be used for training my model, and the rest of the 20% data will be used for evaluation. And I'll be using root mean squared error metric for evaluating the performance of my model. So when you actually see these models trained, you get all these matrices which actually tells you how good those models are. In fact, you can also optimize those models by specifying all the hyperparameters. We did not needed it for this particular use case, so I skipped it, but you can specify these hyperparameters and train, you can optimize your model, and that's it. With that, you'll have a genre model trained for you, and once that is trained, you can actually use it in a prediction pipeline. So I'm reading my data from S3. If you want, you can read it from any source which we saw earlier, and I'll be, reading it in prediction mode. All right, so I'm reading it in prediction mode. I'm specifying the same variables, continuous and categorical, which we trained the model with, and that's it. Then my model will be generating predicted output, which will be processed by this expression evaluator, and finally we'll persist it in S3, where dashboard can leverage it, right? So it's a simple training and prediction pipeline, which is taking the data from actually Q, right? So with that, I think we have our demo part covered. Now let's sum it up. So what we saw is, we saw self-service ingestion. So how easy it is to create a pipeline and how you can actually configure it on a variety of engines, Databricks and EMR, and you can, provide all kinds of auto-scaling capacity to make them scalable. And like a turnkey application, you can configure a CDC. And once all the data is processed, you can actually express all the dependencies on the ETL workflows and create all kinds of automated workflows here. So that's about the ingestion what we saw. And once it is ready, you can build a smart OLAP queue, which is massively scalable on top of the process data, which is clean and, which does not have any duplication. And then you can generate all sorts of insights using a variety of BI tools within a matter of seconds. After that, we can also leverage those cubes as a source for the training and prediction. So that's all we had. Essentially, if you look at it, this end-to-end use case can be created visually, and this can actually give a rapid pace to your development. So that's all we had from the demonstration. Over to you, Larry.
Excellent. I'd like to thank our panelists for a very comprehensive run-through of this topic today, showing us how a unified analytics platform across ETL, machine learning, and BI could actually function in the live demonstration that you've just seen. So thank you, all three of you. This is the time that we move to the Q&A portion of our webinar. We have a couple of things, though, other opportunities for feedback. You'll see a feedback screen, which will allow you to rate your experience in being on our webinar today. You'll see the ability there to enter a rating, but also to add comments and remarks. And we look at all of those, take them very seriously, and use those to improve the user experience of our future webinars. There's also a second poll question there. And that poll question says, would you be interested in a deep dive of the unified product as shown in the webinar today? So would ask you to do both of those, rate your experience in the webinar, and then also let us know if you'd like more detail. Those deep dive follow-ups we have the ability to actually tailor that very specifically to your environment to address the particular features or aspects which seem to be most appropriate in your environment. That being said, we'll move now to the question and answer portion of it. We have quite a list of questions that have come in. Thank you for that. The first one said, is Skywars only available on the cloud? How about on-prem? And Ajay Anand, maybe you could address that.
Sure. Yeah. So Skywars is available both on the cloud, on Amazon, Azure, or Google Cloud, or it's available on your Hadoop cluster or your Hadoop data lake on premises as well. So if you've got, Cloudera, I guess it's Cloudera now since Hortonworks is part of that. But yeah, in your on-prem data lake as well.
Okay, great. There's another one here that asks specifically about applications for the healthcare industry. Does Stream Analytics and Skywars architecture fit in the healthcare industry? It says we're facing challenges ingesting data from an agility perspective, and how could the unified platform help overcome those challenges? And who would like to take that one on?
So I can address the Skywars part of it in the healthcare industry. So basically, when you're dealing with healthcare data sources, there's the issue of privacy that is important, making sure that your data is protected. And at Skywars, we provide the lowest level of granularity in terms of ensuring privacy is maintained. So we can take care of columnar row-level security so that anybody that's looking at the data, so you could have a variety of people in your healthcare enterprise that's looking at the data, and they should only be allowed to see what they need to see. So you can control that access so that a financial person or an HR person or a healthcare professional, they can see different aspects of the data.
Okay, great. Thank you. Obviously, wearables is a big issue in healthcare today, as well as in the ICU environment, the clinical environment, being able to respond to real-time triggers and so forth. And the Stream Analytics product actually is designed to also accommodate IoT applications as they may apply to the healthcare industry. Another question which came in here, Ajay, may be directed at you also. It says, are the cubes created automatically or have to be manually created with data movement? And Ajay, would you like to address that one?
Sure. So as you saw in the demo, it's just a matter of identifying which data sets. So you could have, massive amounts of data in your data lake, right? So now you want to say, okay, these data sets are important to me. So you identify the data sets and let Skywars know that these data sets are the ones that I'm interested in analyzing. And then which are the fields that are important to my analysis. And you can choose as many fields as you want. People can choose hundreds of fields which are relevant to their analysis. And then we take that information and we go off and pre-compute and aggregate the data and create these multidimensional cubes and make that available to all your BI users.
The next question is for Amarjeet. It says, can we implement custom logic for transformation apart from out-of-the-box operators in Stream Analytics? And Amarjeet, if you could jump in and address that one.
Sure. So during demonstration, we saw quite a few operators which we are leveraging in our pipelines, which were built out of the box. But at the same time, the platform allows you to express your business logic in a variety of languages. You can express it in Java, Python, Scala, SQL. And interesting thing is, while you're making these operators in a pipeline, you can also register them so that not just you, anybody who is creating these ETL pipelines in your workspace, they can get access to and reuse them. So yes, apart from out-of-the-box operator, you are free to express the custom logics as well.
Okay, great. There's another question here. Amarjeet, possibly you could answer. What model libraries are available for use with Stream Analytics?
I'm sorry, Larry, can you come again?
There's a question here that says, what model libraries are available to use with Stream Analytics?
Yeah, so there are quite a few actually. So we can leverage Python models. You can actually take advantage of scikit or machine learning, Spark machine learning operators are there. And if you have a model which is created in R, you can always export it in PMML and take advantage of it. H2O is available out of the box. So I think there are quite a few actually.
Excellent. And whoever asked that question, that did come from our live audience. If you need more detail, you can follow up through that unified@streamanalytics.com, and we'll be happy to get back to you in writing. That about concludes the time that we have. We've answered most of the questions that came in from our live audience. There's a couple here that we may, that we'll be able to send out on email. And I want to thank everyone that attended today. Also remind you before you exit, if you would please be sure to respond to our feedback poll. And if you would like a follow-up and be interested in a customized deep dive presentation of the unified product as shown in the webinar here today, we'd be happy to follow up with you and help build out an exact agenda to show that to anyone at your organization that may not have been able to see the presentation today. I would also remind you that if there are those that could not attend or after you've now seen the presentation, you know would be interested, this presentation will be archived on our website, and you can refer them to that, and they'll actually be able to hear the full presentation as you did here today, including the Q&A portion and the Q&A section. Thank you all for attending. Thank you to our panelists for a very comprehensive run-through. This concludes our webinar for today, and please have a great balance of your day. Thanks again.